Hi everyone, we're going to continue our discussion on functions by looking at this special thing called function notation. So, functions, really special mathematical objects, so special and they pop up so often that they deserve their own way of notation. Okay, they deserve their own way of being described, being represented, being defined. Okay. Now, as an example here, I've written down a complete function notation for the function f of x equals x squared. We're going to look at what each of these parts mean, then we're going to see how we can write our own if we've been given an equation and a domain. So, first of all, this thing here at the beginning, this letter, lowercase, that is the name of the function. Okay, so that's all that letter is. It's just the name that we're giving to this function. In this case, it's f. Most of the time, it's going to be f, g, or h. Maybe another kind of letter if you're talking about a specific, I don't know, scenario, real world scenario. But most of the time, we'll be looking at f, g, and h. Okay. This letter here, very important. That is the domain of your function. Okay, now we know what a domain is. A domain is the set of all x values for which your relation is defined. Okay, that will usually be given to you. If it's not, you assume that it is the largest possible domain, which we call the implied or maximal domain. Then you draw this arrow. Okay, that will leave. We don't need to describe what that means. If you want to know what it means something like maps to. Okay, but don't worry about it. You just draw the arrow. And this letter here, this is called the codomain. Okay, now we're not going to look at codomain in year 11. You're probably not even going to look at it in year 12. Most of the time, that will be R. Okay, and these R's stand for real numbers, all real numbers. Okay, it's the set of all numbers. For year 11 methods, this will always be R. It's never going to be anything else. Okay, it's not the range. It is the set that contains the range. Okay, it's a very technical definition. We're not going to go into it. Just remember that that is always going to be R. Okay, however, your domain could be different. Okay, in this case, the domain is all real numbers. It doesn't have to be, though. It's whatever it is in that question. And finally, this part here, separated from the rest by a comma, this is just the rule of your function. Okay, in this case, the rule is y equals x squared. Now this thing here, this f next to some brackets with x inside, we call this, when you say it out aloud, you say f of x. Okay, so the rule is f of x equals x squared. Okay, and we're going to see what this f of x means in the next slide or two. Basically, it's just the y value. Okay, if you were to draw a graph of this function, that f of x is just the y value. Okay, so it's equivalent to the y value. All right, and that's your function. Okay, that's how you write it out. First, you give it a name, in this case f, separate by 2 dots, a colon. You write the domain, whether it's all real numbers or some interval of some kind. You draw an arrow, you write the letter R, comma, and then you write the rule of your function, which you're going to use this letter here, is that letter here. Then you do brackets with x inside, equals whatever your rule is. Okay? And you say that this is f of x equals blah, blah, blah. Okay, so that's all the parts of your function notation. That's what they all mean. The main things you need to remember is this is the domain and this is the rule. Most of the time, everything else is going to be exactly the same. The only things that will really change is the domain and the rule. Sometimes the name will be different. Sometimes it won't be f, it might be little g or little h or some other letter. Okay. All right, so let's have a go at writing our own function notation for some rules. So let's start with, this one. Okay, so what do we need to write function notation? We need two things, really. We need the domain and we need the rule. Okay, so here we've got a rule, y equals 2x plus 3. Okay, so that will be the part that goes at the end of our function notation. Let's think about what the domain of this will be. Now, the domain isn't actually given to us as it's written here, so we have to assume that it's the largest possible domain, which for this rule is all real numbers. Okay, you can stick any number you like into here and it will give you an answer. Okay, that means the domain is all real numbers. So let's give this function a name. Let's call it f and separate by 2 dots here, a colon. What's the domain of this function? Well, there's no where that's telling us what the domain is, so we assume that it's the largest possible one, which is all real numbers. That's a horrible R. All real numbers, followed by an arrow and another R. Okay, that part will always be arrow and an R. And then you write down your rule. Okay, what's our rule? Well, y equals 2x plus 3. Instead of y, we're going to write f of x, okay, the name of our function, f, and then x in some brackets, equals 2x plus 3. That's it. We're done. Okay, that is writing this function in function notation. All right, next example. So we've got this rule here. Okay, this is the rule, y equals half x squared. And this part here tells us what the domain of this relation is going to be. In this case, the domain is the numbers from 0 up to positive infinity. Okay, or the non-negative real numbers, I guess you could call that. So let's have a go at writing this. Let's give it a name. We'll call it g. Okay, what's our domain? Well, we said from 0 to positive infinity, and we're including 0 in our domain. Okay, so one way that you can write that is with interval notation. 0, comma, infinity. There we go. So that's your domain, followed by arrow and R, comma, and then you write down your rule. But instead of y, you write down, in this case, g of x. So we'll say g of x equals half x squared. That's it. Done. Function notation. All right. Next example. Okay, so it's not written in set notation. It's just given us a rule. And that's fine. Okay, we can work with that. All we need to do is figure out what the domain is. Okay, so this is y equals 1 over x squared. So you've got to remember, another way to think about the domain is it's the set of x values that make sense to be putting into that rule. Okay, now any x value makes sense for this rule except for the number 0. Okay, because if you try and stick 0 into there, you'll get 1 divided by 0, which we can't do. Okay, so the domain for this is all real numbers except for 0. Okay, we know the rule, we now know the domain, we can write our function. So let's give it a name, let's call it h. What's our domain? Well, our domain is all real numbers except for 0. Okay, so that's how we would write the domain for this number. Followed by arrow, R, comma, and then you write your rule. Instead of y, we're going to write h of x. H of x equals 1 on x squared. And we're done. Okay? So, main things to consider. What is the domain of your function? And what is the rule? Okay, the domain goes here. And the rule goes at the end. And that's it. That's really all it is. So you've got to be kind of good at figuring out what the domain is of your relation, and then once you've got that, everything else is pretty straightforward. So that's function notation. Another way to talk about a function is to think of it like a machine. Okay, so it's a machine. Here's our function. This machine thing, it accepts some kind of input. Okay, the input is the value of x. And what the function does is it takes the input, it does a whole bunch of stuff to the input, and then it spits out a number at the end, which is the y value, which we call f of x if your function has a name of f. Okay, so your function has like a pre-programmed list of operations that it's going to perform on your input, and after it performs each of these operations in sequence, it spits out a number for you. That is we say the value of the function at x, okay, which you can just write as f of x. Okay, but what that means is the function has a specific value when you give it a certain x input, a certain x value. Okay, so think of it like that. We'll see this again in another video when we talk about the inverse. Okay, we'll return to this analogy. Okay, but that's how you want to think about a function. It's a machine. You give it an input, give it some kind of x value. It does a whole bunch of stuff to this x value, and then it spits out a y value for you to use to maybe draw a graph if you like. Okay. All right, how do we use function notation? So you've got like a rule set up like this. You've got this function defined. For example, we've got this function called f. It has a rule f of x equals 2x minus 1. It's got a domain of all real numbers. Okay, how do we use this? What's the use? What's the purpose of this? Well, one way that we can use this is to figure out what the corresponding y value would be if we gave this function a certain x value. And the way that you do that is you write it in the following way. We say we want to work out what f of 1 is. So you would say this is f of 1. Okay, or in other words, the value of the function at 1. So what will you do here? Well, all you do is you've got the rule of the function. You are now saying I'm pretending the x value is a 1. So wherever I see an x in my rule, I replace that with whatever is in the brackets here. Okay, so for us, in this example, it's just going to be 2 times 1 minus 1, which in this case, 2 times 1 is 2, minus 1 is 1. Okay, that's all it is. Okay, we're evaluating the function at an x value of 1. That's what we are doing. In the second one here, we're going to evaluate the function at an x value of -3. So all you do is you replace wherever you see the x in your function with that value. You replace it with -3. So here we're going to have 2 times -3 minus 1. 2 times -3 is -6. -6 minus 1, -7. And we say the value of the function at -3 is -7. What if it's not a number? What if it's a pronumeral? Okay, well, same thing. You just replace the x in your function with whatever is in the brackets here. And you try and work it out as best you can. So in this case, replacing the x will give us 2 times a minus 1. You can't do anything else to that. You just leave it. Okay, so the value of the function at a is 2a minus 1. And that's the best we can do because we don't know what a is. All right, and the last one here, same thing. You just replace the x with whatever's in the brackets. In this case, 1 over m. So you're going to get something like 2 times 1 over m minus 1. You could write this as 2 over m minus 1. Okay, that's probably the best thing you could do here. At this point, you got to stop, and that's all you can do. All right, so you can say that the value of the function at 1 over m is equal to 2 over m minus 1. And you've sort of provided here that m is not 0, okay? That's a condition that you sort of have to place on m. m is not allowed to be 0 here, otherwise it just doesn't make any sense. Okay, so that's how we use the function notation. Okay, that's pretty much all we use it for. Okay, you just replace the x in the brackets with a number or a letter or an expression of some kind, and you evaluate the function at that x value. Okay, sometimes you'll be getting a number as an answer, sometimes you'll be getting an expression as an answer, depending what you put inside. Okay, so that's it for this video. Here's our summary. Okay, these are the parts of your function notation. You've got the function name, followed by a colon, followed by the domain of the function, which may be all real numbers. It may just be an interval of some kind. Depends on the question. Followed by an arrow and an R. That will always be the case. That should not be a colon. That should be a comma. Sorry. And the last thing that you write out is your rule. Okay, the only thing you're going to make sure that letter here is the same as the name of your function. And you say f of x equals blah, blah, blah. Okay. How do we use it? Well, you've got this f of x here. It means you are putting an x value into your function. The function does something to the x value and gives you a y value, which you call f of x. Okay, it is the function evaluated at x. Okay, so you just substitute whatever number happens to be in here, or letter or expression, you substitute it into the rule of your function, and it will give you an answer. Okay, so that's it. We'll stop there, and I will see you in the next video.